Assalamu alaikum, dear girls. Uh, this video is the continuation of my topic, Bohr's atomic model, right? In the first video, I explained you this topic up to this point, right? Now, I will continue my topic from the fifth assumption of Bohr, and that is electrons can reside in any one of the orbits and not between them. Let's see this picture. Say, this is orbit number 1, orbit number 2, third, fourth. So, electrons may reside in first orbit, second orbit, third, but not in between them, right? This is the fifth assumption of Bohr. Then we come to the sixth assumption of Bohr, that is angular momentum mvr of an electron is an integral multiple of h by 2 pi, right? You know, dear students, that every moving object possesses a momentum, which is the product of its mass and velocity, right? Every moving object has a particular mass and particular velocity. When we take its product, then it is called its momentum. Simple meaning of momentum is the strength, right? But here we are dealing with electrons. The electrons are moving objects and they are doing circular motion. So their momentum will be called as angular momentum because they change their position and angle while moving around the nucleus. So the sixth point of Bohr is that angular momentum, yani strength, mvr, of an electron is an integral multiple of h by 2 pi. Simple momentum is the product of mass and velocity only. But when it comes to a circular motion, then we take the radius of the circle also. So we calculate the angular momentum, right? The product of mass, velocity and radius of a shell in case of an electron, which is the angular momentum is the an integral multiple of h by 2 pi. H is Planck's constant, pi is the area of the circumference of the circle. So let's come to this equation. Angular momentum is represented by mvr, product of mass, velocity and radius. It is an integral multiple of h by 2 pi, and we multiply it with n. N is the number of shell, first, second, third and whatever. M is the mass of electron, v is the velocity of electron, r is the radius of the orbit in which electron is revolving, and h is Planck's constant, and its value is 6.6262 multiplied by 10 raised to power minus 34 joules per second. Let me tell you that the angular momentum of the electron in the third shell will have higher value than the angular momentum of the electron residing in the second shell, which will in turn have higher value than the angular momentum of the electron residing in the first shell. Means the strength of electron which resides in the higher shell will have higher angular momentum, higher strength than those residing in the lower shells or orbits, right? So n stands for represents the number of shell. Say if it is first shell, then we will multiply this whole structure with 1. If it is the second shell, the angular momentum of the second shell, then we will take value of n as 2 multiplied by h by 2 pi, and certainly it will have higher value than that of the first shell electron. If suppose we are taking the angular momentum of the electrons residing in the fourth shell, then we will take n as 4. We will multiply h divided by 2 pi with 4, and it will certainly have much higher value than the angular momentum of the electron residing in the third, second or first shells. So this was the mathematical calculation of the Bohr's atomic theory model, and I hope it will be clear to you. If you have any difficulty regarding the any step of this topic, you can give me feedback and I will try to explain it, to re-explain it, to sort it out, inshallah. Thank you very much.